exactly is welding? So welding is when you're actually fusing the materials together by heating up the base metal. And I'm just going to use this as an example. So you're heating up the base metal, and then you are fusing it together with a filler rod. And usually in welding, you have some sort of shield because you're trying to keep all the other elements that are in the air out of that weld. Things like nitrogen and stuff can make your weld very brittle. So you want to kind of shield it as you're fusing those two pieces together. Whereas something like soldering is when you are just heating up the solder itself. The base metal never changes. You're just joining it together with the solder. Where this, you're actually breaking it down and rearranging it to stitch it together. So what we do here at University Theater is mainly just very simple stuff. We don't get into stainless or galvanized and stuff like that. We just do a lot of basic welding. So we use just mainly steel. There's a lot of other welding videos out there that you can check out that go into depth on all that stuff, but we're just going to be talking about steel. So some of the things that we use, this is one of the most common pieces that we use, which is 1 inch by 1 inch box tubing. So you can see it's just kind of hollow, and we try to go with a light gauge to kind of keep scenery light. We use other things such as 1 by 2 box tubing. So this is going to be a little sturdier. So you kind of think of this kind of as your 1 by of scenery, and this is more of your kind of 2 by 4 of scenery. So it's a little, but it's of course smaller. We also lots of times have to weld steel pipe together, various sizes. And then other things that come in handy a lot of times is just angle iron. So this is great putting pieces of scenery together. But and then this is a 1/2 inch by 1/2 inch box tubing. So these 3 items are usually what we're using. We're using box tubing and also pipe. So those are the big ones. So of course, there's a lot of safety concerns, and I'm going to pull out my notes here because there's a lot of things that can go wrong. Burns. You can burn yourself very easily because you are melting steel, right? So it's getting very, very hot, and it doesn't cool down instantly. So when I weld something together, this whole thing is going to be warm. It's going to be really hot right here where the weld is, but the whole thing is going to be warm. So when that's warm, you don't want to touch it, of course. And you also want to be careful with your equipment. You don't want to lay your equipment onto a hot weld that could damage it. So you need to watch out for that. The type of welding that we do here in University Theater is MIG welding, which is an electrical arc welding. So you have electricity, so you have the shock hazard, so you need to protect yourself from that. Vision damage. This is a very, very bright light when you're welding, and we'll get into some of the PPE. There are gases that come off of this when you're fusing them together because you are melting things, especially things like galvanized and other items like that. There's also ultraviolet radiation that comes off of it, so you have to be careful about that. Fire is bad. And also cuts from sharp objects, because when you cut this stuff, it can be very, very sharp. So let's talk about the PPE. So there's lots of PPE, personal protective equipment, that we can wear. Let's start with the gloves. Here. So heavy duty leather dry gloves. You need to make sure that they're dry. If your hands are getting sweaty, you need to get another pair of gloves, because this is what is helping insulate you from the work so you don't have electric shock. So dry gloves. We go for the heavy duty, the kind that cover up over the sleeve. Some people use lighter duty gloves when using a MIG welder, but we like to try and make sure that we're being safe and use the heavier duty gloves. A long sleeve shirt that covers all the skin, because you do not want to get the ultraviolet radiation. It will turn you very red, and it does not turn into a suntan. So something that is also a natural fiber, like cotton. You do not want any synthetic materials, because that will melt. You would rather have something burn rather than melt into your skin. So jeans are great, but also you need to have a long sleeve shirt. A welding helmet. So this welding helmet is a nice one because it is a auto dim, which means it has sensors in here that dim automatically as soon as you start welding. Once the light changes, it automatically dims the helmet for you. There are other helmets which are just a fixed shade. So it's always kind of dark when you put it on. So when you're doing your work, you have to kind of get set up and then drop your hood down, and then you can start working. Whereas this, you can see through it, it will automatically darken. And you've got some settings as far as how dark the shade is and delay and sensitivity. So the auto dim are very, very nice. I always like to wear a hat when I'm welding. I usually like a baseball hat because of the brim, because a lot of times you'll get some slag coming off and it will drop down into the collar of your shirt. So I like to have the brim on the back of the hat to kind of keep that out of the back of my neck. And safety glasses, of course. So it's always good to keep a pair of safety glasses on, even with the helmet, because again, that slag will jump all over and it will jump into your welding helmet sometimes. So go ahead and wear some safety glasses too. So always a good thing. Let's see. So pants, what I didn't mention is do not put any cuffs into your pants. That slag that's jumping around can go into the cuffs. Also, you don't want any frays either. You don't want any cotton frays that can also catch on fire from some of that slag. Let's see. So the other thing that you have to be worried about is other people that are around. So if Mike is in this area and I'm about to weld, I need to let him know welding so he can divert his eyes so he's not looking at the weld. So it's always good to say welding when other people are around that could be exposed. Exhaust fans and respirators too. Again, depending on the materials, it can be some really toxic gases. So we use a ventilation system that kind of pulls the air up and out. Hoods are great. You can't really just put a fan onto something, because with this, we've got a gas that comes out. If you put a fan on it, you're just going to blow that shielding gas away. So something that extracts the fumes away from you is much better. You need to keep your area free of combustibles. Or what we like to do around here, because we're in a big wood shop, is we build a little fort. So we take some bifold flats and just kind of put them around and keep that slag from jumping into bins of wood and things like that. So we kind of protect our environment by kind of closing it down. And then that way we keep someone on fire watch that watches for that slag, and we keep a little spray bottle of water and also a fire extinguisher just in case, so you can shoot those little pieces of slag if they run away too far. Let's see. Also, when you're done cutting, or especially welding, you do not want to leave the area for 30 minutes. You need to keep an eye on everything. Make sure you didn't set something on fire and it's smoldering, and eventually it's going to turn into a fire. So you always need to make sure that you're keeping an eye on everything. And the other big thing is you need to keep all your equipment in good working condition, because you don't want to try and make repairs on something such as this if you are not qualified. So again, if you have any questions, throw them in the Q&A. Mike is standing ready by the phones, ready to answer any of your questions. So different types of welding. I think so. Just going to kind of use this nozzle, kind of talk about the different types of welding. Even though this is a MIG welder setup, we're just going to kind of talk about it like it's some of the other welding equipment. So the most basic welding is oxyacetylene welding, which is when you have two tanks. You'll have an oxygen and acetylene or some other gas. And those two gases are mixed together in a torch. You open up the gas, you take a sparker, and then you light the torch. And now you adjust the gas to where it's a nice temperature. You warm up your material, and then you have a filler rod, which helps fuse the materials together. So you're, again, warming up that base metal, and then you've got a filler rod that's helping join that together. So it's kind of a two-handed operation. So you've got the heat, which is also a shield, kicking out any of those bad elements that make a weld brittle. And then you got your filler rod. MIG welding is, actually, let me go back to arc welding. So arc welding was kind of the first arc welding that they did. So basically, you are, again, with electricity, creating an arc. So you have in arc welding, you have two clamps like this. And they call them a work clamp. They call the other one sometimes a ground clamp. It's not actually grounding. It's just completing the circuit. So if I had this clamp on this metal table, then it's going to kind of run the circuit through the table. But with my welding rod in the arc, you've got that filler rod. And that filler rod becomes the electrical arc. So you're taking your rod and you're actually striking an arc. Because if I took my rod and just stuck it to this, it's just going to complete the circuit and it's just going to get stuck. So arc welding is tricky because you're trying to, it's almost like striking a match. You have to get that circuit to connect, but you don't want it to be complete. So you're holding it off about 3/8 of an inch or 1/4 of an inch, depending on what you're doing. And you're creating a very hot electrical arc. So that filler rod, as you're welding, is just melting down as you are moving. In arc welding, the rod is covered in a flux that becomes the shielding agent. So that flux burns off as you're welding, and it's pushing, again, those bad toxins, not toxins, but elements out of the air, pushing it away to make a nice little environment. That slag actually cools on the weld as you're going, so it kind of actually helps protect it. So when you're done using an arc welder, you have like a skin over the weld. And it's just a very thin skin. So a lot of welding brushes you'll see has this hammer on there. So after you're done, you take the hammer and you knock that slag off, and then you can clean up your weld. So arc welding is very simple because the only thing that you have, this is your only expendable. This is not a welding rod, this is just an example. But the welding rod is your only expendable. So you're just buying a big tub of, of filler rods, and that's all you're kind of burning through, is just those. And there's all kinds of different welding rods, depending on what you're doing, how thick you're going, how much you need to fill, things like that. So then they came up with MIG welding, which is what this setup is. Now, this gun, the electrode, the rod, what's making that arc is fed through the gun from the machine. Also fed through the gun is the gas, which is a shielding gas. So this is not a combustible gas. This is a gas that, again, is pushing out those other elements and shielding it. And then this, as you are pulling the trigger, this electrode is constantly being fed through. So it's just a steel coated in very thin copper to protect it. But we'll come back to the MIG welder a little bit more, talk about some of that after we talk about the other one. So another type of MIG welder, again, is if you did not have the gas, what you can do is a flux core MIG welding. Same kind of thing. You've got the electrode that comes out, but inside the wire is your flux, which as it burns, it gives out a gas, which is, again, a shielding gas to help protect that weld. Another type of welding is TIG welding, which is tungsten inert gas welding. So TIG welding, instead of having this electrode that melts, you have a tungsten element on there that does not melt, but it makes the circuit. So again, you have an electrical arc, but this is not melting. This is just creating that arc, which is creating heat. So now you have to, again, use a filler rod, which then stitches that metal together. So TIG welding is pretty cool, but it's a little complicated because you've got a lot of different things going on. There's also other welders that can do it all. So they've got some multi-processor welders that you can change out the different leads. You can have it be an arc welder, you can have it be a MIG welder, you can have it be a TIG welder. Because you've got your power, you've got your gas, and they're just kind of combined all into one. So the MIG welder, again, this is a metal inert gas. So the MIG welder is, has the carbon-argon mix, and it is a 75% argon and 25% carbon dioxide mix. So that is your shielding agent. So you've got two gauges on here, you've got your tank pressure, and then you've got the amount of gas that is coming through the line into the machine. So when I open up the machine, you can see there's a big spool of wire. So when I pull that trigger, that spool is just pushing that wire through up to the gun. And then at the end of the gun, so you've got your trigger here. When you pull the trigger, that pushes the gas out, and also pushes the electrode out. You've got a nozzle on the end, and this one's a little dirty. So you need to keep that clean so the gas comes out. You have a contact tip out here. So this is kind of where it's getting the electrical connection there. So then put your nozzle on, and this is where the gas comes out. When you have this out, you want to have it out about 3/8 of an inch. And something that's always very handy is a pair of welding pliers. So I don't have my safety glasses on, but you trim that off. This is also very good for cleaning out that nozzle when it's nice and dirty. The controls on the front, there's two main controls. So you've got your voltage and your wire speed. So the voltage increases, decreases the voltage, and then the wire speed is how fast that wire feeds through. So this is a lot of fine tuning depending on what you're welding. So if you're welding something thick, you're going to need some more voltage to help melt that steel so you get some good penetration down into the steel. Because you don't want it to be like a solder. You don't want to join it together just on top. You want to penetrate deep down into the steel to melt it together. So trying to find the wire speed and the voltage is kind of like trying to figure out a stick shift on a car. So you're trying to figure out how fast is it coming out and where should I let my clutch out. So it's kind of the heat and the speed. So there's a lot of fine tuning that you can do. And before you start welding on something, just take a piece of steel and just do some test welds. Make sure that you like what you see, then you kind of work on your project. Let's see if I forgot anything. Again, this is the work clamp. Some people call it a ground clamp, but again, you are not grounding this. This is completing the circuit. So you have to, usually people just kind of clamp onto whatever they are welding. So I think that's it for the MIG setup. So now that we know how the welder works, now we need steel. So we're going to come over here and we're going to talk about cutting the steel. Because we're going to just we'll take this piece right here, just a 1-inch box tubing. And this is an abrasive cutoff saw. So this has an abrasive wheel on it that wears out as you're cutting. It's kind of like a very rigid piece of sandpaper almost. So this just gets worn out as you're cutting. And we can do an example because it's a lot of fun to watch all the sparks fly. So just gonna clamp it down there. When you're measuring, you wanna use something that will show up easily, like chalk, or something like a silver Sharpie shows up on steel very nicely. And then I need my safety glasses, which are over here. And then I'm gonna put my earbuds in because this is a little loud. Okay, good. after you cut that, that's going to be really hot. So an abrasive cutoff saw is great. The biggest problem with it on the bottom is that you always get this sharp little burr here. So you always want to file that off. You need to be very careful with that because that's just kind of razor thin right there, and you can cut yourself very easily. Even on the inside, you can see that burr is inside there. So a lot of times you got to clean that out because if you leave that exposed, someone could stick their finger in there and again cut themselves. So abrasive cutoff saw is a great saw. You can change the angle here in the clamp to be able to get different angles. There's other saws, which we do not have, but there is a cold cut saw, which is similar, except instead of an abrasive blade, it's just a carbide tipped blade, which is not expendable. It just is really sharp. And I can't just put one of those blades in here because it spins at a specific speed, which does not correspond to how fast this one spins. So maybe someday I can get one. But the biggest problem with that is it's even louder than this one. It's really loud because, again, you're taking chunks out of steel with a spinning blade. So it's really, really loud. But you don't get that little burr on there because it's a clean cut. So you save a lot of time by not having to clean all that stuff up. Something else that we use quite a bit for cutting is a horizontal bandsaw. So it's a bandsaw on a base. So you put your material in here, clamp it down, flip on the switch, and this makes a nice slow and steady cut. But again, it's a clean cut. It doesn't have that burr. So it takes a little bit longer to cut, but you don't have to do the cleanup. And again, you can change the angle on this one so you can get different cuts. It's a very slow and steady, nice and easy kind of saw. The portaband is another band saw, but this is nice because now it's very portable. So I can take it over to whatever I'm cutting and take this to the material. Slow and steady, but it's a nice cut. Other things that you can use to cut is just a metal cutting blade in a Sawzall or in a jigsaw. It's going to take some time. And again, there's a lot of vibration in that because it's just kind of going back and forth rather than the bandsaw being just a continuous cut. A grinder with a metal cutting blade in it is nice. So this blade, is very thin. You can see, so it's good for kind of cutting through. And again, it's another abrasive blade. So that will be another expendable. It wears out as you're cutting. So those are kind of the big cutting tools. So another thing that's really cool that we do not have is a plasma cutter. So plasma cutters are really cool. It's an electrical channel of superheated electronically ionized gas. So you can cut through much thicker materials, and it's just kind of like a blowgun of just melting through your steel, and it's really kind of cool. And again, maybe someday we'll have one of those, but for now, any one of these do most of the work for us just fine. After you cut the steel, then you kind of need to clean it up because again, you've got that burr. So you can change out your cutting wheel on your grinder to a grinding wheel. Which one? Which one? This one? All right, so you can see that one's a little thicker. So that's for grinding. So you're going to take that grinding wheel and you're just going to grind all that stuff off so you can get rid of it. Or you can take your stationary grinder and you can take your steel up to it, clean it up that way. So just turn it on, take it, clean it off. Other things that you need to do, steel is always coated so it doesn't rust. So you've got a film on here, it's a grease. So you need to take something like this, which is a degreaser, spray it down, take a rag, and wipe it off. Because that's going to affect the electrical flow going through it, so it needs to be clean. You need to get any rust off. You need to get paint off. If you're recycling, reusing, and it's got paint on it, you need to grind that off. So you can use, again, a grinder and kind of grind some of that stuff away. Or you can use a wire brush, or a wire brush, or a cup. Or another thing that you can put in your grinder is a little flap disc, which is pretty much like sandpaper. So that will clean up things quickly. So now that you've got your steel nice and clean, welding setup, I was kind of talking about this table before a little bit. So this table is great for small things, if you're doing very small things that will fit on the table, because you can put the clamp on the table. Whatever you put on the table is going to complete the circuit. So you don't have to worry about putting your clamp on it and it falling over and stuff like that. You just put the clamp on it and you're good to go. When we get into larger things, then we're gonna want to lay things out on the floor or on the table or something like that. A lot of the things that we do are very large, so we'll do it on the floor and we'll draw out on our floor and we'll use things like jig blocks, which are just small pieces of wood, and we'll put those down around whatever we're welding. So we just place our wood down, and sometimes we'll put it on that side so everything lays out where it's supposed to be. And after we're done, we just pull up the jig blocks out of the floor. So welding, once you kind of weld it together, it's not like wood. You can't kind of tweak it and stuff. Once it's kind of welded, if you're crooked, then it's going to stay crooked. So having a nice square table and doing a nice layout on the floor with jig blocks to make sure that everything is where it's supposed to be is very important. So there's a lot of setup in welding as far as cutting it, cleaning it, grinding it, getting it ready, laying it out, and then finally tacking it together. Let's see. So different kinds of welds. So who's that one? So this is just a very simple spot weld. So a lot of times I'll do a little spot weld. If I am trying to weld something like this together, if I start welding on top, a lot of times the heat has a tendency to kind of pull it together like that. So a lot of times what I'll do is I'll just put a little spot weld in the corner just to tack it down so it doesn't move. Then I can do a weld on the top, and it's going to keep it from curling in. It's just the heat will kind of pull that and bend that around. And then you don't notice it when you flip it over, and now you've got a big gap there, and this isn't quite square anymore. So spot welds are very handy. Just a butt weld, when you just want to weld two pieces together. A lot of times what we're doing is T-welds, T-joints, something like that. We're at the corner. With these, you have to be careful because you've got more steel on this side rather than there because you've got this nice strong corner. So when you're welding, you have to kind of stay over on this side and slowly kind of join this together. Otherwise, you'll melt through the thinner side quicker. So it's kind of a figuring out where the thick wall is and where the thin wall is, so you're not just blowing through and making a hole in your steel rather than joining it together. A V-butt is when you're having a thicker material and you want to get good penetration. So sometimes you want to kind of angle that joint, and this is just rounded, but it's a good example of now I've got some good penetration in there just by getting rid of some of that material in the middle. Now I've got a spot for my weld to lay into, and that makes it a very strong joint. And then of course there's other just kind of overlaps like that where we're just kind of bridging it together. There's different types of stitches, we'll call them, but usually it's called beads. So when you're running a bead, some people like half circles, some people like circles. So I like to think of it like if you are making pasta. You've got your flour, which is your base, and you make a little hole for your egg to go into. Your egg is the weld. Then you're taking your egg and you're slowly incorporating the egg into the flour as you're mixing. So I like to do little circles and just grab the sides of that steel and just slowly bring it together over to the other one and stitch it together like that. Some people just like to do stitches, just half circles, just kind of going back and forth like that. Again, you're just bringing one side of the steel over to the other, and you're just mixing it together. You're fusing this together. Other people just like to do zigzags. So they just kind of do a zigzag, zigzag, zigzag. So again, you're going over here, you're grabbing some of that steel, and you're pushing it over onto this side, pushing it over onto that side. But again, this was some practice welds, but you can see it's just kind of stitched together, taking it from here over to there, over to here, over to there, over to here, over to there. So those are the different types of beads. Spots, circles, half moons, zigzags. Next, we're going to talk about, we're going to show some pictures. So it's picture time. So we're going to look at some of the stuff that we've done in the shop. So I'm going to do a little screen share. All right, let's see. So this was a staircase from Jekyll and Hyde. So this was the bottom of the staircase. This was the handrail coming up the side. And then this was the top of the staircase. So again, you can see our little fort. We like to make forts around here, kind of keep everything contained to make sure that, you know, nothing jumped over here and found a little pile of dust over here, sawdust or anything. This is a good example of the jig blocks going around. So we kind of draw this out on the floor to make sure everything is nice and square and where it should be. You can see some chalk lines there. Most of the time, keeping the jig blocks out of the corners so you can get into here to be able to weld the corners and the tops together. Let's see. So this is just another angle of it looking this way. So yeah. And then this is the two sides put together now with the stringers kind of joining them. So these were made separately. And then we joined the whole thing together with more on the bottom for the wheels and the casters and everything. And you can see our fort grew as the stair grew. This was getting finished off. So now that the frame was done, now we came back with some wood, and we just take some self-tapping screws for this one and screwed them into the steel to help give this some detail. And then here it is painted, or first coat, base paint. And then this was it in the show. So this fit up on top of the platform, and it would go around to various spots on stage for entrances and exits. This was Secret Garden. The steel structure here, if you can see it here, this whole thing was leaning at about a 15-degree angle, kind of coming out towards the audience. So we needed something pretty substantial to be able to kind of support that. So we used 1x2 tubing, and usually you couldn't see it in the show. It was just at this moment, this reveal moment where the lights in the back kind of came through and you can really see the steel. Most of the time you couldn't really see it. It was pretty dim. But this was scrim kind of covering it. So it was very ghost-like, and because there's a lot of ghosts in the show. But this was the structure itself back behind. And so there were two pieces to be able to transport it, and these bolted together once they got over there. So that was it from the front. You can see that angle again, and you can see some ghosts in the back. This was ragtime. We did a lot of steel handrails for this show. These actually came from another theater that made the bottom parts. We wanted them a little bit taller. So all we had to do was just weld on these top pieces. We had to cut them down, of course, to make them fit what we were doing, but someone had put this together for a show and we're getting rid of them. And we, right at the same time, we were doing an industrial looking show too. And we said, we'll take those. And welding is nice because, again, we just had to grind away some of the paint where we wanted to weld it on and just kind of add it on. So we had to create a couple more to be able to match what they had. But now you've got a super strong handrail system up there. And then just another shot. You can see down below. This was Urinetown. Again, lots of handrails. This was Lovesick. This was, we did something that looked like a drop ceiling kind of frame in a department store with the lights that were attached to it. So this was all just suspended from our grid. I believe it was in 3 pieces. And again, just kind of bolted together. But really kind of made a nice clean look up above the stage. Same kind of thing for Colored Museum. So we had this grid up top where the lights kind of mounted onto, and they actually were the supports for the walls too. And then you can't really see it here, but this is Alice in Wonderland. And there's a lot of scrim on this show. So there's these big panels that came out along the proscenium and then halfway along, which they were 20-foot tall, 16-foot wide panels just made out of steel that had scrim wrapped on them. So we're, again, trying to go very minimal framing and then just with scrim. So it was used for projection and just lots of different things. So we've got actually lots of time left. So what we can try and do is we can do some, you want to try and capture some welds?
Sure, yeah.
Yeah? Got a little project that we're working on, so I need a little shelf. So I kind of already got the other side. but we want to make sure this is nice and strong. So we're going to come back and we're going to kind of weld on this side too. Gonna put on my hat. Put on the welding jacket. Again, you don't want any skin exposed. Again, it helps cut down on any burns, but also insulates you at the same time. So glove. All right, so again, the gas is already set. I've got the voltage and the wire speed set to where I like it. I want to make sure that my gun isn't sitting somewhere where the trigger is automatically pulled when I turn it on, because then that wire is just going to spool out. But actually what I'm going to do is I'm going to do this. So I'm going to turn it on. So now it's on. So who's close up? Kevin? All right, nozzle. So I'm going to pull the trigger and you can just see this wire just come out. At the same time the wire is coming out, the gas is coming out too. So that's the wire speed that I've got set up. Right, so I pull the trigger and the wire comes out. Nothing else happens. Now, once I bring it over here, now I'm going to kind of complete that circuit. So it's going to be passing through. Again, that's why you want to insulate yourself from your work. You want to make sure that you're wearing good insulated shoes. Also, I did not mention shoes. So you want to wear something with a good sole, closed-toed. You don't want hot slag falling on your feet, so no flip-flops. Again, this is helping protect you, insulate you. You can use a rubber mat also on the floor to help kind of insulate you from the work. So. All right. All right, so your angle, you'll always kind of want to try to be right over top of it. You don't want to really be this way. So it's going to be a little weird. Let me see if I can get a better angle for you. We didn't really work this out. So I'm going to go this way. So I'm going to be slightly angled going this way. I'm not sure how we're going to do. So we'll see. All right. All right. Welding. That was awful. I was all over the place. But so I kind of went this way and that way. Again, I'm at a strange angle. I'm trying to stay out of the way for a shot. But it's as simple as that. So a lot of people kind of call this the hot glue of welding, because all you're doing is you're pulling the trigger and you're just kind of gluing it together. So that was an ugly weld, because it's just kind of on the surface. It's over here, it's over there. I'm stitching these together here and here. I'm kind of off right there. But that's one nice things is you can come back and you can remelt that and again, try and get a good stitch, a good weld going. And if you build it up too much, you can take that grinder and you can grind it down so you can make it nice and smooth. Because again, you're penetrating down into that steel. So that steel is now stitched together. After you weld, a lot of times you'll get this little ball on the end. You kind of want to trim that off again with your pliers, because now that's a lot more resistance in the wire. So it's going to kind of stick or pop off, and it kind of makes it kind of an ugly weld at the very beginning. So it's usually good to, that one's pretty small, so it's not too bad, but it's good to kind of keep that trimmed off. And again, you want the stick out to be about 3/8 of an inch or so. All right, let me see if I can do one more. Welding is very awkward. It's just, you got these big heavy gloves on, you got this helmet on, you got this on, so everything about it is a little awkward. So let's see. Welding. So I kind of sped up a little bit too much because I heard it sounded like I was kind of starting to burn through. So again, not the prettiest weld, but it's joined together. It's not horrible. And that's really all there is to it. So again, I'm kind of doing the little swirls, just kind of trying to stitch. See, I'm kind of going over that way. I always kind of weld this way. So it's just, should we try that? Can you see it? Okay. Welding. Burn through. Oh yeah, you can see it better. Okay, so that was what I was talking about. So I was too far on that side. So that sidewall is a lot thinner than the corner of the steel. So I kind of blew through over there. I think I'm gonna stop because I keep doing bad welds here. So yeah, you can see it just kind of, I've got a little buildup here, but I just kind of melted the steel right there. But that's fine because again, this is a filler rod. I can come back and I can fill that hole. It's just about slowly filling it back in and then coming back and then making a nice little stitch. I really do kind of think of welding kind of like stitching. You are stitching the two things together. You're joining it, but I still like the pasta analogy where you're incorporating the flour together into this other material.